Hello everyone, I'm Golden. I'm here to present a TinyOS and in ad hoc and wireless sensor networks. On completion of this, students will be able to explain what is TinyOS and how it works. So first of all, we need to see TinyOS. Especially, actually, this is designed for sensor networks. So TinyOS is an open source, flexible, component based, and application specific operating system. So TinyOS support concurrent programs with very low memory requirements. So the OS has a footprint that fits in 400 bytes. So the TinyOS component library includes network protocol, distributed services, sensor drivers, and data acquisition utility. So TinyOS architecture, actually TinyOS architecture shown in the figure. You can see it. So TinyOS falls under the monolithic architecture. A class which is depicted TinyOS uses the component model and according to the requirements of an application. So different components are glued together with the scheduler to compose a static image that runs on the mode. So a component is an independent computational entity that exposes one or more interfaces. Components have three computational abstractions: commands, events, and tasks. So mechanism for inter-component communications are commands and events. So tasks are used to express intra-component concurrency. A command is requested to perform some services, while the event signal that the completion of the service. So TinyOS provide a single shared stack, and there is no separation between kernel space and user space. Then tiny program model. So in a earlier version, actually TinyOS did not provide any multi-threading support with the application development strictly. So following the event driven the model. Then TinyOS version 2.1 provides the support for multi-threading, and this TinyOS threads are called TOS thread. Then TOS thread use a cooperative threading approach, that is TOS thread rely on application to explicitly yield the processor. Then next one is TinyOS scheduling. So TinyOS scheduling. Early versions of TinyOS supported a non-preemptive first in first out scheduling algorithm. Therefore, those versions of TinyOS do not support real-time application. So the core of the TinyOS execution model are tasks that run to completion in the first in first out manner. Since TinyOS support only non-preemptive scheduling, task must obey run to completion schematics. So task run to completion with respect to other tasks, but they are not atomic with respect to interrupt handlers, commands, and events they invoke. As TinyOS uses first in first out scheduling, disadvantages associated with first in first out scheduling are also associated with the TinyOS scheduler. Then TinyOS memory management and protection. So in sensor nodes, hardware based memory protection is not available and has a resource or scarce. So resource constraints necessitate the use of unsafe and low level languages. The next one is TinyOS communication protocol support. In the earlier version, actually TinyOS provided two multi-hop protocol, dissemination and TYMO. The dissemination protocol reliable delivers the data to every nodes in the network. Actually, this protocol enables administrators to reconfigure queries and to reprogram a network. So the dissemination protocol provides two interfaces: disseminations value and dissemination update. Then the next one is TinyOS resource sharing. Here it uses two mechanisms for managing shared resources, visualization and completion events. So visualization resource appears as an independent instance, that is the application uses it independent of other applications resource that cannot be visualized or handled through completion event. The generic communication or the stack of TinyOS is shared among different threads and it cannot be visualized. Generic actually can only send one packet at the time. So send operations of the other threads fail during this time. So such shared resources are handled through completion event that inform waiting threads about the completion of particular job. The next one is TinyOS support for real-time applications. So there is no explicit support in the TinyOS for real-time applications. It is not only good for a choice for sensor networks that are being deployed to monitor real-time phenomena. So an effort has been made to implement an earliest deadline first process scheduling algorithm, and it has been made available in newer version of a TinyOS. However, it has been shown that a EDF algorithm cannot produce a feasible schedule when task content for resources. So TinyOS does not provide any specific MAC network or transport layer protocol implementations that support quality of service requirements of real-time multimedia streams. So at the MAC layer, TinyOS supports TDMA, which can be fine-tuned depending upon the requirements of an application to support multimedia data. Thank you. Thanks for listening.